Hi, and welcome to the review on solutions. The PowerPoint's already been uploaded to Schoology, but I wanted to give you an example of some of the problems. Most of them are fairly straightforward. There's an example problem of each one in the book. I'm going to do one with you, but solutions are physical combinations of substances. So they're different from elements and they're different from compounds. Gold is always gold, NaCl is always NaCl, always in the same ratio by mass. That's not true with solutions. It's not true with mixtures. A mixture is a physical combination, so they're fairly easy to take apart, different from a compound, and they might have different quantities. So you have to know the terminology before you can understand how to do the math. A solution is a homogeneous mixture. That means it looks the same throughout, and that's what the math that we're going to be using in this chapter is based on. It's on these homogeneous mixtures or solutions. So the solution is the whole thing, like salt water. Salt water is a solution. That's the whole thing. There are two parts that make up the solution. There's the solute, and it's spelled S-O-L-U-T-E, but it's pronounced solute. That's the part that gets dissolved. So in the case of table salt in water, salt water, the table salt itself, the solid that you put into the water, that's going to be the solute. The solvent is going to be the part that does the dissolving. So a solute plus a solvent makes a solution. That's the whole thing. The solvent does the dissolving. It's almost always water, but not always water. But it is very frequently water, especially in the problems that we're going to do. So the two parts together make up the entire solution. And besides just having ways that we can describe the solution, like if you think of orange juice or iced tea, if you make sweet tea, some people put a lot of sugar in their sweet tea, so that's considered concentrated, and some people don't put very much, and that's considered dilute. And those are called qualitative descriptions. So you have a qualitative description, you're not using the numbers. In chemistry, we have to use the numbers, and that's what the series of equations that are behind me on the chalkboard are based on. These are all the equations that you should be putting on your equation sheet, and there's a section of sample problems for every single one as a homework assignment. So the first two are pretty self-explanatory. They're just percentages. There's a percent mass and a percent by volume. You just have to be very specific as to what you're measuring. The numerator of both of those has to do with the solute, and the denominator has to do with the entire solution. So you're taking a part and dividing it by the whole thing and then multiplying by 100. So you have to pay attention in the problem. Are they talking about the part that's getting dissolved? Are they talking about the solvent? Do I have to add them together to get the whole thing? You might have to do that. It's a percentage, and then you get the percentage when you're done. So the main thing that you have to do when you're reading these problems is pick out the solute, pick out the solvent. Most of the time, like I said, it's pretty easy. The solvent is almost always water, but there's another way of figuring this out. The solute is always in a smaller amount. So if they're both in grams or they're both in milliliters for the percent volume or the percent mass, you just have to see which one is there a smaller amount of, and that's going to be your solute. To get the total solution, you're going to have to add the two together. So the part divided by the whole thing times 100, that's going to be the percent mass and the percent volume. The second part of this chapter then started dealing with a very specific way of figuring out the concentration of usually a liquid solution, and that's molarity. Molarity stands for the capital M on the board, and it's in moles per liter. Once again, very specific. The numerator of that equation is going to be the number of moles of solute. That's the part that gets dissolved. The other part is going to be the number of liters or the volume of the solution, but very specific. It has to be liters. It can't be milliliters. You have to change it to liters. The other equation that has similar letters, this has to do with diluting a substance. So if you have a solution that's too concentrated, like hydrochloric acid, and you want to dilute it down to make a weaker acid or one that is not going to have such a high molarity, you're going to use a proportion where M1V1 is the concentrated part of the solution, and M2V2 is the more dilute solution that you want to create. The M's are the molarities and the V's are the volumes. The next equation is called molality. It sounds like molarity, but it's slightly different. Also, we use a lowercase m to represent molality. Almost the same equation. It's going to be the number of moles of solute. This is the different part, and the number of kilograms of solvent. So once again, solute plus solvent equals solution. Everything up until now has had the solution in the denominator of the equation or the percentage. This one does not. This has to be in kilograms, and that's what you're going to have the solvent in. The last one is a mole fraction, and it's exactly what it sounds like. You're going to take the number of moles of the solute, and you're going to divide it by the moles of the entire thing. And it's just a ratio. There's no unit involved with that. It's just to show the mole fraction of the solute in a particular solution. The last equation over to the left
That's called Henry's Law. Henry's Law is specifically just for gases that are in a solution. Like if you have oxygen that's been bubbled into water for your aquarium, you would use Henry's Law. S1 and S2 are the solubilities. P1 and P2 are the pressures under which the gas is kept in the solution. So there is a problem on the board, a sample problem, and I'm going to be putting a problem of the day until our test on the board. But you need to try to do this one, and then you need to check with me after you've watched this video to see if you need some extra help in getting the correct answer. But we're actually going to go over this one in class as well. So hopefully that's a good enough description of what the equations are for and how we use them. If you want to see an example of each one, there are examples in the book, or I can help you individually when you get back to class. But I did want to give you an update on this.